Hey Geometry. In today's funness, so I'm sitting in my office today. I have two boys playing video games, and not gonna lie, they're loud. And I am going to try to record some videos. Just want my face in a place where I look at the right place, and I'm not like looking down, looking over, looking up, looking down. I'm actually looking at you. That was fun. All right, so let's get started. Unit 2, Lesson 6. So we've already talked about all the congruence theorems except one, but in the curriculum, we're actually going to go through them just a little bit more, okay? So this is Lesson 6. We're actually talking about side angle side triangle congruence. Let's do our little warm-up. So highlight each piece of given information. Let's get the highlighter going. That is used in the proof, and each line in the proof where a piece of information is used. Okay, so we have many given things. So all of these items are given. All right, and now we're going to talk through the proof a little bit. I'm not sure how they want us to show our answers. So highlight each piece of the given information that is used in the proof. Okay, so when we see it used in the proof, we're going to highlight it. Segments A, B, and DE are the same length, so they're congruent. So AB is congruent to DE, needs to be highlighted. Therefore, there is a rigid motion that takes AB to DE. Cool. Apply the rigid motion to triangle ABC. The image of A will coincide with D, and the image of B will coincide with E. So that means we know that angle A is congruent with D, and B is congruent with E. So we need to highlight those also. Just double checking. Okay, that one was a little weird. Yep. All right. Oh, and we found that first one in proof line 1. Okay, I actually am going to erase these. I'm not sure the points coinciding means that they're congruent. All right, but definitely AB is congruent to DE is found in proof line 1. All right, we cannot be sure that the image of C coincides with F yet. It is necessary, if necessary, reflect the image of triangles ABC across segment DE to be sure the image of C, which we will call C prime, is on the same side of DE as F. The reflection does not change the image of A or B. We know that the image of angle A is congruent to angle D. So, put my highlighter back on. In that line, we're definitely going to highlight angle A is congruent to angle D. Okay, very cool. Now, line 5 says that C prime must be on ray DF since both C prime and F are on the same side of DE and make the same angle with it at D. Cool. Moving on, segment D C prime is the image of AC, and rigid motions preserve distance, so they must have the same length. But that is not anywhere in our givens. Okay? Segment D C prime is the image of AC, and rigid motions preserve distance, so they must have the same length. We also know that AC has the same length of DF. Ooh, that sounds familiar. So AC and DF is right there. AC is congruent to DF. So DC prime and DF must be the same length because we set up here, it's not highlightable, but we set up here that they're the image of each other, so we're going to use that right here. Since C prime and F are the same distance along the same ray from D, they have to be in the same place. So we have shown that rigid motions take A to D, B to C, and C to F. Therefore, the triangle ABC is congruent to triangle DEF. And I believe we used, let's see, AB, we used this side, is congruent to DE. We also used AC, is congruent to DF, and we also used angle A is congruent to angle D. So we used side, angle, side. Okay, side, angle that's included, and side. I don't like these types of proofs. I'm going to be honest with you. I prefer just 2-column proofs where I make a statement and I support it. And then I make a statement and I support it. And I make a statement and I support it. I don't like writing paragraphs. Okay? I just don't I write them because, as human beings, we all need to be really good at writing paragraphs. But I prefer 2-column proofs. So whenever I write a proof for you, that's what I'm going to model. All right, so proving the side angle side congruence theorem. All right, 2 triangles have 2 pairs of corresponding sides congruent, and the corresponding angle between those sides are congruent. We're calling that, in our words, the included angle, because it's between those 2 sides, so it's included in between them. Sketch 2 triangles that fit this description and label them LM, N, and PQR. Okay? So I'm actually going to open up. I can't because my face is in the way. So what we're going to do, come on. I hope I didn't need that. So I'm actually going to, let's see. It doesn't tell me which sides to make everything, does it? 2 triangles have 2 pairs of corresponding sides congruent, the corresponding angles congruent. Sketch 2 triangles that fit this description, LMN and PQR. I really don't want to rename these, but it's okay. Okay, so I'm actually going to copy this. Let's just duplicate. There we go. Like, why can't I actually grab it? So these are the same length. Let's just rename this one. This is taking a little longer than it would be if we were just P. Q. All right, so I need another segment. We're just going to go off here, make it, I don't know, that big. And we want this to be, oh, no. We don't want that. N. And let's go ahead and duplicate this. Didn't want to shrink it either. All right. Okay, what's tragic here is the length of this, which used to be the same length as that, is no longer. So maybe that wasn't the best idea. So let's go ahead and see if I can grab it. Good. But now they're not going to be attached. All right, they're going there. And this one is going here. So I sort of translated this segment up here, translated that segment down there. So the angles are the same. Now I should be able to make a segment between them. Well, let's do this. Let's actually show that measurement. Should be the same. Yep. And this angle measurement should also be the same. Cool. Cool. Let's move that. Now, because I have constructed 2 segments with an included angle that are all equal, I should be able to connect those to the open ends and have them be the same length too. Because we know that side angle side matching with side angle side is a congruence statement. It's a triangle congruence statement. So these should be the same size also. Missed it. And they are, okay? That's no mystery. If it didn't work, there'd be something wrong with the world, but it works, okay? All right, so we just did this. LM is congruent to PQ. We didn't have them named the right way, but we did it correctly. LN is congruent to PR. Angle L is congruent to angle P. And then using a sequence of rigid motions, take LMN to PQR. We actually used a sequence of rigid motions to copy them, okay? We translated it, directed line segment. We actually, oh, not that one. We translated it with a directed line segment. Where's my vector? Or array. Construct. Always takes me a second to find the right thing. Nope, not that. Here we are. Vector. So we just translated it this distance. Why didn't it work? Okay, how about this one? Vector from point. Starting point and vector. We're making a vector. So I had the wrong thing selected. Okay, so really that vector should be the exact same measurement as this vector and that vector. Okay, we did a translation. That's all. Look back at the congruent triangle proofs you've read and written. Do you have enough information here to use a proof like the one you saw earlier? Use one of those proofs to guide you in writing a proof for this situation. So I'm actually going to go right here. I wonder if I can insert space. Maybe? Oh, well, that might be enough. All right, so watch this. Wrong thing. Let's grab it. Actually, I'm going to, I want to delete these vectors because they're just going to be in my way. And then I'm going to do a screenshot. And put that right in here. Nope. Why is it way over there? That's very inconvenient. Oh, there we go. Okay, and there's my chin right there. I'm going to handwrite a very basic proof in the style that I like to write it. So I'm going to say that, need a pen, P1, N1 is congruent to Pn because it's given. And then we can, because that's how we constructed it. And then P1, Q1 is congruent to PQ because it's also given. See how I have a column and a column? And then I can say that angle P1 is congruent to angle P because it's given, because that's how I constructed it. Now I can say that triangle P1, Q1, N1 is congruent to triangle PQN because of side angle side. All right, so really I have a column which moves down here and a column. And these are all my statements and reasons. Okay, that's how I write proofs. And I just think it's so much easier, and maybe that's just because how my mind works, than writing a paragraph. Cool? Just want to model that for you a little bit. Activity synthesis. Let's see. I don't know if I can select. No, we don't want to do that. I was hoping to move all that stuff down. Oh, it worked. Oh, it didn't work. Okay, let's not do that. Okay, that used to say reason. All right, I'm going to try one more time because I think I can do it. And now I'm going to select it and move it down. Cool. Can I move this? No. Okay, so here in this activity synthesis, we see, I'm going to highlight. So if I look at AB is congruent to GB, AB, GB, and then I can see that BC is congruent to BC because they're the same. And then I can see that angle ABC is congruent to angle GBC. So what we see there is side angle side. Oh, that should be blue. Highlighter. There we go. So I would do that the same way. I would write AB is congruent to GB because it's given. Then I would write BC is congruent to BC. And you can write given there because it is. Another reason we use for that is reflection is what you'll see because it's a reflection. Or you can say because they're the same. Okay? And then the angle ABC is congruent to angle GBC because it's given. And then the last thing you would say is triangle ABC is congruent to triangle GBC because of side angle side. Okay, that would be another column proof for you. Let's move on. All right, what do we know for sure about isosceles triangles? Mai and Kieran want to prove that in an isosceles triangle, the two base angles are congruent. Finish the proof they started, draw the auxiliary line, and define it so you can use the side angle side congruency theorem to complete each statement. So we're going to draw a perpendicular bisector, and we're going to draw it. We would construct this with our compass and straight edge. Okay, perpendicular bisector through point A. Okay, so I would do, this is A, that's B, this would be point P. If I did a circle through A, the radius of AB, and then through B, the radius of AB, we know in an isosceles triangle P is between it. So now I can just draw a segment through it. That's terrible drawing, but I think you understand what I'm trying to do. So I'm going to draw a perpendicular bisector. So now we know that PA, let's change colors here. PA is congruent to segment PB because of the definition of isosceles triangle. And angle B is congruent to angle A because of the definition of isosceles triangle. Let me make sure that's the way that they used it. Because, again, the book tries to simplify things, actually, and that's why it's different. I guess the way I learned was more complicated, and the way I've been teaching for years is more complicated. Ooh. Okay. No worries. We're just going to go a different route. Should have read ahead. Can I lasso this and delete it? Yeah, that's awesome. Let's go ahead and eraser. Oh, no. Large eraser. So they actually want us to draw an angle bisector, which is much easier to draw. If I do a circle around P, and then I have an intersection here and an intersection there, And then I put my pointy end of my compass there, and I do a little arc out here, pointy end of the compass here, and arc out there. It constructs an angle bisector. Okay? Now, I want a smaller eraser. Let's do medium. I don't want my construction lines, because that's just going to make it hard. But I just constructed an angle bisector, okay? All right, so, oh no, I thought I was still erasing it. Angle bisector. Of angle bisector of angle APB. Now, angle, so PA is congruent to PB. I can mark that because that is a definition of isosceles triangle. And then I can say that angle APQ, is congruent to angle BPQ because of my angle bisector. That's how I made it, right? And then segment PQ is congruent to itself. So really what I have here is that's congruent to that, and PQ is congruent to itself. And we can say reflexive property, reflexive, or just say same. Therefore, triangle APQ is congruent to triangle BPQ by the side angle side congruence theorem. So therefore, we would just say that angle A is congruent to angle B. And then my reason, that would be my statement. My reason would be CPCTC. Congruent parts of congruent triangles are congruent. So that is a much simpler proof. So that's a little bit between what they've been doing already and what I do with my columns. I really like the fill in the blank proofs. And here we've got the same thing. So AP is congruent to PB because it's an isosceles. That would be a statement, and my reason would be definition of isosceles triangle. Then angle A is congruent to angle B. Same reason, definition of isosceles. And now we just need that side. If you construct a perpendicular, bisector for an isosceles triangle, it cuts everything in perfect halves too, okay? So, yeah. Something else I want to point out to you, though, is just what an isosceles triangle is. I want to make sure we all understand. Isosceles triangle just mean, like the definition of isosceles triangle, two opposite sides are congruent and the base angles are congruent. Okay? And we use it a lot because if I told you these two base angles were, say, I don't know, 30 degrees, if that's 30 degrees, you know that this one's 30 degrees. Therefore, you can say 30 plus 30 is 60, 180 minus 60 is 120. So we know the top is 120. And if I drew either an angle bisector or a perpendicular bisector, that cuts it in half, which means this is 60 and that's 60, and this has to be 90. Okay, 60 plus 90 is 150, plus 30 is 180, always. I mean, the 30 and the 60 aren't always, but when you do that bisector, it's perpendicular, it's 90 degrees, and that triangle sum theorem holds true for any triangle. All right, I think that was it. Activity synthesis. All right. What auxiliary line would you add to the diagram to help you use side angle side? So, auxiliary line. Because that's congruent to itself. Okay, I'm not sure what else is going on here, but I bet you're going to get some givens that say things like, oh, I bet that's congruent to that. bet this angle is congruent to this one, especially if these are parallel, because then those angles are alternate interior. Okay, so I can prove those two triangles, let's say FEG is congruent to triangle HGE. Make sure you get it in the right order because of side angle side. Okay, I just made half of that up. Here, again, I would probably draw that, and here I have side angle side is congruent to side angle side. We didn't even need that middle being congruent to itself, did we? So I could use side angle side for this one, or side 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 for that one. Okay. What else? Make sure I get, yeah, BC is what I would draw. This last one, I have radius and two angles, and then this one, I don't think I have to draw anything because I have side congruent to side. Let me highlight it. Side congruent to side, angle congruent to angle, and side congruent to side because they're the same. Because IL is congruent to IL. And then I can say IJ is congruent to IJ, and angle JIK is congruent to angle KO, JIL. JIL is congruent to KIL. So I have side, angle, side. Not in that order though, because that order's bad. Remember, this angle, I'm going to take a second and do one more thing. Sometimes when you're just learning proofs, it helps a lot to put them in the order they should be. So if I did JI is congruent to IK, because it's given, given, and then angle, JIL is congruent to KIL because it's given. And then we can say IL is congruent to IL, which was not given, same or reflexive. Now we have side, angle, side in the right order. Okay? All right, I'm going to stop it there. Good job. That was a little long.